In the world of software, one of the biggest challenges we face is actually one of the simplest to describe, just moving data from point A to point B. It sounds so easy, doesn't it? But as you'll see, the choices you make about how you pack up that data for its journey, well, they can have absolutely huge consequences for speed, for cost, and believe me, for the sanity of your developers. So to really get this, let's start with a question that has absolutely nothing to do with code. Imagine this. You've got a fully assembled IKEA bookshelf. It's beautiful, it's holding all your books. It's a live object in your living room. But now you need to ship it to a friend across the country. What do? You can't just shove the whole thing in a giant box and hope for the best, right? It would never work. And this whole puzzle, this IKEA problem, is exactly what software engineers are up against every single day. The only difference is we're dealing with data instead of furniture. A live data object sitting inside an application's memory is just like that assembled bookshelf. It's super useful right where it is, but you can't just send it over the internet as is. So what's the solution? You take it apart, of course. You carefully dismantle it back into its original flatboards. You bag up the screws, you find the instructions, and you pack it all neatly into a flat box that's easy to ship. In our world, the software world, this process has a name. It's called serialization. It is literally the art of converting a complex, living data object into a simple stream of bytes that can travel across a network. And then, naturally, when your friend gets that flat pack box, what do? They open it up, they follow the instructions, maybe with a little frustration, and they rebuild the bookshelf in their own living room. It becomes a useful object all over again. And that reverse process, that's what we call deserialization. Taking that stream of bytes and turning it back into a live, usable object on the other side. Seems pretty straightforward, right? Well, this is where things get interesting, because this is where the real decisions begin. Just like when you're shipping something in the real world, there isn't just one type of box. You could use a plain old cardboard box, a heavy wooden crate, or maybe even a super efficient vacuum-sealed bag. Each one has its pros and cons. And in software, these boxes, well, we call them data formats. Okay, let's start with the most common one out there, the one you've probably heard of, JSON, which stands for JavaScript Object Notation. The best way to think about this is as the standard cardboard box. It's absolutely everywhere, it's pretty much free to use, and almost everyone on the planet knows how to handle it. So what makes JSON so popular? Well, for starters, it's text-based. That means you, a human, can actually open the file and read it, which is a huge deal when you're trying to figure out why something is broken. It's basically the common language, the lingua franca of the web. Pretty much every programming language can understand it. But it's got a downside. It can be a little chatty. It tends to waste space by repeating the names of the data fields, which we call keys, over and over and over again. All right, next up, we've got XML, the extensible markup language. Now, if JSON is our cardboard box, then XML is the heavy-duty wooden crate. It's older, it's a lot bulkier, and it's way more rigid and structured. You see, XML is super structured. It uses these things called opening and closing tags for every single piece of data. That rigidity makes it great for systems that need really strict validation. Think about banking systems or government applications. But all that structure comes at a cost. It's massive. An XML file can easily be double the size of the exact same data in JSON, which means it's slower to send and takes more effort to process. And finally, we get to the high-tech option, protocol buffers, or Protobuf for short. This was developed by Google, and it's not really a box at all. This is the vacuum-sealed bag. It is precision-engineered for one thing and one thing only, maximum insane efficiency. So Protobuf is what we call a binary format. And what that means is if you tried to open one of these files, it would just look like a total mess of gibberish. You wouldn't be able to read a thing, and that's on purpose. It gets rid of human-readable field names like username and replaces them with simple numbers. The result? Incredibly tiny file sizes and processing speeds that are just blazing fast. The catch? You absolutely need the original instruction manual, a special file called a schema, to make any sense of the data at all. So, all of this, it really brings us to the core conflict, right? The fundamental trade-off that every single engineer has to wrestle with when choosing a format. It's a constant battle between two competing needs: readability for the humans who build the system versus efficiency for the machines that run it. The choice really comes down to this. Who are you building for? Are you building a public API where other developers from other companies need to easily look at the data and figure out what's going on? Then you're optimizing for humans. You should probably use JSON. Or are you building an internal system where your own services are firing data back and forth thousands of times a second? In that case, who cares about human readability? You're optimizing for machines, and that's where something like Protobuf absolutely shines. Okay, so that's the theory. But let's get real for a minute. When would you actually pick one of these boxes over the other in a real-world project? Think of this table as your cheat sheet. Let's run through it. If you've got a web browser talking to your server, you're using JSON. End of story. Browsers speak it natively. Now, what if you have your own services, your microservices, all chatting internally at a really high volume? That's when you reach for Protobuf. Those savings in bandwidth and speed, they translate directly into saving real money on your server bills. Dealing with an old banking system or some legacy enterprise software? Yeah, you're probably stuck with XML. And finally, what about configuration files that humans need to open and edit? JSON or something similar is the way to go. I know what you might be thinking. Are these little differences in file size really that big of a deal? Let me tell you. At scale, this choice isn't just a nerdy technical detail. It can literally be a billion-dollar difference. Let's just look at the raw numbers for something super simple, like a single user profile. Okay, in XML, that data might take up around 400 bytes. Not bad. With JSON, you can cut that in half, down to about 200 bytes. That's a great improvement. But then look at Protobuf. The exact same information is squeezed into just 50 bytes. That is an 8 times reduction from XML. 8 times! And yeah, a couple hundred bytes here and there, who cares, right? But what happens when you're a company like Google, and you're sending this user profiles data not once, but billions of times every single day? Suddenly, that difference isn't measured in bytes anymore, it's measured in terabytes. And that's not just some abstract number, that's fewer fiber optic cables you need to run under the ocean, fewer servers you need to buy and power, it's a faster experience for every user, it is real money and real performance measured in the millions, if not billions of dollars. All right, so after all that, what's the takeaway? How should you actually make this call in your own projects? Let's just boil this all down to one simple, final rule of thumb you can take with you. It really comes down to this simple path. Step 1, just start with JSON. Seriously. It's simple, it's universal, and it's the right choice probably 90% of the time. Step 2, you move to something like Protobuf only when you have a very clear performance problem, when you've actually measured it, and you know that data size is your bottleneck. And step 3, you use XML only if you absolutely have to, like when a legacy system or some big enterprise partner puts a gun to your head and forces you to. And that brings us to the most important idea of all. The best data format isn't always the fastest one or the smallest one. It's the one that best fits your specific bottleneck. Is your biggest problem machine performance? Or is it the time it takes your developers to build and debug the system? Answering that question, well, that is the true art of data transport.